All right, number 4. What is the factored form for this big old expression? So the first thing I'm going to do is factor out the GCF. They all have an x in common, and I know that they can be divided by 2, but I don't know if they can be divided by 4. 144 divided by 4? Yeah, they do. Okay, so these all have a 4x in common. So factor out a 4x. It's going to leave me with an x squared there. 4 times 9 will give me 36. So there'll be a 9x, and then minus 4 times, it looks like 36. 36 will give me the 144. All right, so now I want to try to break this trinomial into 2 binomials, right, into its linear factors. So I need to find the factors of 36 that will subtract to give me 9. They got to multiply to 36 and subtract to 9. It's going to be 12 and 3. All right. The 36 is negative, so they're different signs. And the bigger number is going to be positive. Okay. There we go. Awesome. All right, number 5. To solve this for x, because I've got a fraction equal to a fraction, I can cross multiply. So I'm going to do x times the x minus 27. And that's going to equal the 5 times the 10. Distribute on the left-hand side. That's going to give us x squared minus 27x equals 50. Let me think about this for a second. Darn it. I'm going to have to go back and change this. This original problem was supposed to be a negative 50 right here, I'll bet. Yeah. So change that to a negative. Let's see. This way, whenever I move the 50 to the other side, it's going to be x squared minus 27x plus 50 equals 0. This is actually solvable. All right, we can solve this one by factoring. So the factors of 50 that will give us 27 are 2 and 25. 2 and 25. They're both negative. Okay. If x minus 2 is a factor, 2 is the solution, and 25 is the solution. Okay. So plugging in 25 for both of those x's should balance the equation. On the left-hand side, if I had 25 divided by negative 5, 25 divided by negative 5, that should equal 10 over 25 minus 27, which is negative 2. And yes, these are the same thing. You get a negative 5 on the left-hand side, and you get a negative 5 on the right-hand side. 2 works as well. Right? If you plug in 2, it will give you, it'll balance the equation. All right, number 6. What is the sum of the first 50 numbers in the sequence? So I think on this one, we're going to need, to have our one of our formulas. Let me pause the video and find that. All right, so there were 2 formulas for finding the sum of the sequence. This formula, the one on the left, you have to know the first term and you have to know the last term, but we do not know the last term in this sequence. Like we would have to make up our own formula to figure out what the 50th term in the sequence was if we wanted to use that formula. So for this one, we have the first term. We know that there's 50 numbers in the sequence, And we also can figure out the common difference. The common difference is 7, because that's just what they're going up by. 8 to 15, they're adding 7. 15 to 22, they're adding 7. All right. So the setup is going to be n divided by 2. So 50 divided by 2. All right. 2 times the first number in the sequence, which is 8, plus it's going to be 50 minus 1, so 49, and then times the common difference, which was 7. Okay, gotta work all this out, and that's going to be my solution. So you could work it out on the calculator, or you could simplify it first. 50 divided by 2 is 25. 2 times 8 is 16. 49 times 7 is 343. Okay, and now we could simplify it. 16 plus 343 is equal to that, and then we're timesing that by 25. So 8,975. That is what they total up to.